So we are given four. So the question. We are given four signals S1, T, S2T, S3, and S4T. You can see all the four waveforms. And whatever question is to find our orthonormal basis. So in short, we need to find phi1, phi2, and so on. So and as we also know that number of orthonormal basis function will always be less than or equals to m, where m is number of signals. So our number of signal is 4. So our n will be less than or equals to 4. So we will see that 3 or 4, whatever number of basis function will be required, right? And how to verify that this number of basis functions will be required, right? Because after finding phi 3, you can calculate phi 4, okay? But you will get that 0 or it will be dependent. So we will see this thing by solving this example. Stay tuned. So let's start. So the very first step was to calculate phi 1t, right? So our phi 1t is given by, as we already know, our phi 1t is simply S1t upon under root of E1, which is nothing but E1 is the energy of our S1t signal, and we know S1t signal is this. Okay, I need to verify this page again and again, right? Because all the waveforms are here. So you can calculate easily the energy of this signal. Just energy E1 is integration minus infinity to infinity S1 square t dt. Since magnitude is 1, 1 square will be 1, and we have to integrate in 0 to 2. So we are integrating 0 to 2, just dt, right? So our answer will be 2. So our energy is 2. So I am just writing this as S1t divided by root 2. So the very first function we already got. This is, as we all know, it's easy. Now let's move towards second function, and before that let's just plot. So just we have to divide the signal S1t by its magnitude with the factor 1 by root 2. So what is our S1t? I need to refer again and again here. So S1t has magnitude 1, right? As you can see here, 1. So here just we will be plotting the same thing, but with the reduced magnitude of 1 by root 2, because we are dividing by root 2, right? So we will refer this phi 1t as well. That's why I am drawing each and every figure. So we will be referring in future this thing as well. Now step number 2, our aim is to calculate phi 2t. Now how we will calculate phi 2t? So phi 2t can be calculated by using some intermediate function, as we already discussed. So let's say this function is g2t and it is given by this. Now we need to calculate s21t first, is our scalar, and we know how to calculate its s2t into phi 1t and dt. So we have to check both the waveforms s2t and phi 1t, and we have to multiply. So I hope you all can do this, that we have to check s2t here and phi 1t, which we already plotted, and we have to multiply both of them, right? So you can see that we have to break the limit at 1, right? I hope you all know this basic thing. So from 0 to 1, both have magnitude of, one has 1 by root 2 and one has 1. So multiplication will be 1 by root 2. So in 0 to 1, I have magnitude of 1 by root 2 dt. And from 1 to 2, phi 1t is again 1 by root 2. But let's see for this. This is minus 1. Okay, I forgot to mention. This is minus 1. So if we multiply, then we will get minus 1 by root, right? So from 1 to 2, we have minus 1 by root and dt. So if we calculate this, then obviously we will get 0, right? So it means that our S2t is 0, so this entire term is 0. So at the end we are left with G2t as S2t, simple, right? Now we know that this G2t is equals to S2t, but this S2t is having some energy, and in order to get phi 2t from G2t, what we have to do? We have to just divide this G2t by its energy, and G2t is nothing but our S2t. So in short, we need to divide by energy of S2t only. So we have to divide it by energy. So let me write energy as under root of minus infinity G2 square t dt. And we know that since G2t is equals to S2t, I calculated here. Let's say energy of signal S2t is given by E2. So this you can easily calculate from the figure of S2t. I'm not going again there. So this is our S2t. You can calculate. Okay, so I calculated and I got 2. So at the end, our phi 2t is S2t divided by root 2. Clear? So let's just plot. So same thing, we have to divide S2t magnitude by 1 by root 2. So here it will be 1 by root 2. If it was 1, S2t, then verify S2t by going again to the waveform of S2t. So this is minus 1 by root 2, this is plus 1 by root 2, this is 2, this is 1. So now we are having phi 1t and phi 2t both. Now let's move towards phi 3t. So our step number 3 is, our aim is to calculate phi 3t. And again, we will use intermediate function, and this time the function is given by this, right? So how will we calculate S31t now? Similarly, S31t is given by S3t, then phi 1t and dt. So we have to multiply S3t with phi 1t. So please calculate what is this, that where is our S3t? S3t is here, and we have phi 1t here. So in 0 to 2, it's constantly having 1 by root 2, phi 1t, whereas S3t is having breaks from. So here you can see that S3t is having from 0 to 2, okay, it's having 1, and from 2 to 3 is also having minus 1. But since phi 2t is not having, right, if we multiply, then it will be 0. I think multiplication with 0 is 0. So now we are left with, I hope you can easily calculate only with this limit from 0 to 2, it's 1 by root 2 dt, right? Just keep both the signals side by side so that you can easily do this, right? So it will be root 2, correct? Please let me know in the comment section if the calculations are wrong, right? So that we can verify. Now similarly, S32 can be calculated as S3 of t, phi 2 of t and dt. So S3 of t and phi 2 of t, so just quickly see, phi 2 of t is here and S3 of t is ranging from 2 to 3 as well, but phi 2t is ranging only from 0 to 2, right? So we have to break from 0 to 1 and from 1 to 2, right? So let me just write on the next page, right? Is equals to from 0 to 1, we are having, just keep the signal side by side so that you can easily write this thing, okay? And again we are getting 0 this thing, right? So our G3t can be given by simply S3 of t minus root 2 times phi 1t. Since I am just substituting this in this equation. Since this term is 0, so we are left with this two thing, and I substituted the values. That's it. So we got S3t. Now let's just plot this function G3 of t, right? Because we need to calculate its energy in order to find our phi 3 of t. In order to find phi 3 of t, we have to normalize this G3 of t by its energy, just this thing, right? So first of all, our task is to find this function, and this is simple, just signal multiplication and subtraction like this. So I am just plotting it side by side. Next page. Sorry. So let me just plot first S3 of t again. So I am just quickly plotting S3 of t. This is t. This is S3 of t. S3 of t ranges from, sorry, this is 1, this is minus 1. It's there with not to scale. Okay, scale to here. So this is minus 1, this is 1. Then this is, we have root 2 times phi 1t, right? So let us just plot root 2 times phi 1t, and then we will subtract this two things. So we already know phi 1t is multiplied by root 2. So we are left with this magnitude because our phi 1t has magnitude 1 by root. So we are multiplying by root 2, so we are left with 1. That's it. Right? Now just subtract this two. If we will subtract this two, as you can see that from 0 to 2 both are 1. So from 0 to 2 both are 1. So if we will subtract, our answer will be 0. And from 2 to 3 only S3 is there, and since we are subtracting S3t minus root 2 phi 1t, because this is nothing but our G3 of t, right? And we need to find its energy. So we are just left with 2 to 3 and the magnitude is here minus. So now we can easily calculate this G3 of T energy. We are calculating energy of this. So simply we will be minus 1 square from 2 to 3. I'm just writing quickly and dt. So we will be 3 minus 2, which is nothing but 1. So at the end we are left with this term as 1. So phi 3t is also equal to G3 of T. Right? And G3 of T is nothing but this. So just let me put all the things together. That phi 3 of T is nothing but G3 of T. And G3 of T is nothing but S3 of T minus root 2 times phi 1 T. So we are having phi 1 T, phi 2 T and phi 3 T. All the three equations now we are having. Right? So let us just put them in the box and just name them. So here we have phi 2 of T. So this is equation number 2. And the very first page we have this as equation number 1. Right? So we have this phi 3 of T now. Now let's say we go to step number 4. Now we will see that whether this step number 4 is required or not, because we know that n is always less than or equals to 1. Right? So let's try to see this. That if I will write G4 of T equals to S4 of T, writing quickly, S41 of phi 1 T, then S42 phi 2 T, then sorry, this will be minus. All will be minus. I hope you all know why this is minus. So we will calculate S41 of T. S41 of T will be S4T into phi 1 T into dt. So if you multiply these two signals, so I'm not explaining because it is very easy now. So this will be minus 1 by root 2. I urge you to calculate this and you will get minus root 2. Then similarly, you can calculate S42 as S4 of T. Please verify all this calculation so that if there is any mistake, then you can rectify. 0 to 1 minus 1 by root 2 to dt and will be from 1 to 2. I have all the figures plotted side by side, that's why I am writing quickly, right? But you can do this. And similarly, S43 we need to calculate. Let us take S43 is given by S4 of T, phi 3 of T. It will be from 0 to 3, 1 times dt, from 2 to 3. And then it's 1. So at the end, if you substitute all the scalars, it is S41, S42 and S43. In our equation, we are left with this thing minus phi 3 of, and which is nothing but this is equals to 0, right? Because how it is 0, now we might wonder. If you will plot S4 of T, we have all the signals, right? If you will plot S4 of T, then do 2 times phi 1 of T and phi 3 of T, and if you will apply this thing, that is add this two and then subtract, then you will not get any signal, you will get 0, right? So G4 of T is not required. So this is nothing but we killed G4 of T. Please remember my lecture number 1 in which I said that we killed here G4 of T. Over there we killed V3 of T or V3 vector, right? So here we killed G4 of T because it's not needed to specify in signal space diagram these 4 signals S1, S2, S3 and S4, right? And that's why Graham Schmidt said that n should always be less than or equals to 1. Here n is less than n because m is 4 but n is 3, right? So at the end, what we can say that here we got our S4, but this equation is useful, right? Here G4 of T is not required, no doubt, but this equation is useful because since we are getting 0, because we need to specify S4 of T as well. in terms of phi 1, phi 2, phi 3, phi 4. It is nothing but our signal space representation, right? So if we just, because since this is 0, right hand side is 0, just adjusting this equation, we will get S4 of Ts minus root 2 times phi 1 t plus phi 2, right? So we are having our final equation as well. So our task was to find phi 1, phi 2, phi 3. So we find. Now the next task was to represent in signal space diagram, right? And for this representation, we need phi 1, phi 2, phi 3, right? So we calculated phi 1 t, phi 2 t, and phi 3 t, right? Now our aim is to sketch this signal space diagram. So how we are going to sketch? First of all, in order to sketch all the signals, what we want is that we want to write all the signals in terms of phi 1 t, phi 2 t, and phi 3 t. Okay, so we already made box of those equations. So first is this one. Let us try from the first one. So here, if you can adjust, S1t is nothing but root 2 times phi 1t. So quickly I am writing S13 as root 2 times phi 1t, right? So since we are having three basis function, so we can write root 2 comma 0 comma 0, and all the vectors are basically column vectors. So since I am representing in the form of row, I can write this transpose. Okay, this is just the notation. Similarly, we can write S2t. Just please see S2t. So what was our S2t? S2t is root 2 times phi 2t. So I am writing S2t as root 2 times phi 2t. So this we can represent like 0 comma root 2 comma 0. It's transpose. Now S3t. So S3t is here, right? So if you can adjust this, S3t is given by phi 3 root 2 times phi 1t plus phi 3 1t, right? So just writing given by root 2 times phi 1 of t plus phi 3 of t. So nothing but root 2 comma 0 comma 1, which transpose. At the end, we have S4 of t like this, minus root 2 times phi 1t plus phi 3t. So I am writing minus root 2 times phi 1t plus phi 3t. We can represent it as minus root 2, 0 and 1. And the transpose. Here. Now we are ready to plot our signal space representation. So let us take new page to plot. Okay, it's a straight line and view. Yes, so that's it. Phi 1, phi 2 and phi 3. This is 3D. This is phi 2 of t. This is phi 1 of t. This is phi 3 of t. Because we have this right-handed coordinate system. So S1 of t is given by, this is S1, this is nothing but 2, 0, 0. For S2 was, so here is 0, 2, 0. For S3 is somewhere in the plane, because S3 you can see here that our S3 you can see it is having some root 2, 0 and 1, right? So let us plot just S3. Root 2 will be positive, right, and 1 will be also. So root 2 will be here and 1 will be somewhere here. 1 is in 3D or something. Yes, it is for coordinate. So we will be having somewhere here like S3. It's root 2, 0, 1. It's not in this phi 2 space, right? It's in just phi 1 and phi 3 space, right? So we can plot vector. All these are vectors. Okay? This is a vector presentation. At the end, our S4t is minus root 2. So we have to go to minus side. So if this side is plus, then this side will be minus. So this side I'm just extending as minus phi 1t coordinate. So we have minus root 2 and 0 and then 1. So we will be having S4 of t somewhere here, like minus root 2, 0. Right? So of course plot the vector till here, origin. Right. So this is our signal space representation of our S1, S2, S3 and S4 segment. So I hope you enjoyed my video. So this concludes my series of Schmidt, and I hope I will see you in the next lecture. We will be solving one more example. Right? So stay tuned. Thank you.